Okay, let's dive right into this. Today, we're going to pull back the curtain on the magic that powers pretty much the entire internet. We're going to demystify the backend, that powerful, invisible engine that makes everything you do online actually work. I mean, really think about it for a second. You fill out a form, you click a button, and poof, it all just happens. It feels totally instant, right? But in that little split second, your request is actually kicking off an incredible journey. And that's the story we're going to tell today. So first things first, when we talk about the back end, what we're really talking about is everything you don't see. It's the server, it's the database, it's all the application logic. It is literally the hidden machinery that brings a website or an app to life. To put it really simply, backend development is all about what happens on the server. Look, if the website you see in your browser, the front end, is like the dashboard and the steering wheel of a car, well, the back end is the engine, the transmission, the fuel tank. It's the part that does all the heavy lifting. So our journey starts with that engine, Node.js. You see, for years and years, JavaScript was a language that only lived inside your web browser. But Node.js, it was a total game changer. It let developers use that same JavaScript for both the front ends and the back ends. It's like being able to build the entire car with just one set of tools. And wow, what an engine it is. With Node.js, you can build these incredibly fast, scalable web servers. You can manage files on the server, talk directly to databases, build the powerful APIs that are like the central nervous system for modern apps. It is just so incredibly versatile. But what is it that makes Node.js so famously fast and efficient? Well, the secret sauce is this really cool concept called the event loop. It's the magic trick that lets a Node server handle thousands of connections at once without even breaking a sweat. And it all comes down to one key idea. Never, ever wait around. Okay, to really get the event loop, you have to understand this one difference. Synchronous code is like a single lane road. One car has to finish its entire journey before the next one can even start. It is a traffic jam just waiting to happen. But asynchronous code, well, that's a multi-lane highway. Node can start a slow task, like asking a database for information, and instead of just sitting there and waiting, it zips over to the next lane to handle other requests while that first one finishes up in the background. So here's how it all comes together. Any really fast, simple task gets handled immediately in what's called the call stack. But the slow stuff, the heavy lifting like getting data, that gets sent off to work in the background. Once those tasks are done, they patiently line up in the callback queue. And the event loop? That's our traffic cop. It's constantly looking over at the call stack. And the second it's empty, it waves the next finished task from the queue right through. This whole system is what makes Node so incredibly efficient. Now, having a powerful engine like Node.js is great, but you still need a chassis, a steering system, and, roads to follow. That's where Express.js comes into the picture. It's a framework, and it's so important because it gives our powerful engine a clear, organized structure to work with. So we're not just building absolutely everything from scratch. And a huge part of that structure is something called routing. The best way to think of it is like a digital post office. When your request arrives at the server, the router looks at the address, the URL you're trying to reach, and makes sure it gets delivered to the exact right department to be handled. And what's really cool about this slide is it shows you what that routing actually looks like in the code. And you totally don't need to be a programmer to get it. This is just a signpost. It's telling the server, hey, if a GET request comes in looking for the /user's address, I want you to run this specific function right here. It's really that simple. Okay, so routing gets your request to the right department. But before it's handed off, it often has to go through a few security checks first. This is where middleware comes in. Just think of them as a series of checkpoints that your request has to pass through, where each one can inspect it or even modify it on its way to the final destination. Yeah, you can almost picture it like an assembly line. The request comes in. The first middleware station might just log what time it arrived. The next station checks to see if you're logged in correctly, and if you pass all of those checks, you finally reach the end of the line, where the actual response is prepared for you. All right, so our request made it through the router. It passed all the middleware checks. Now, what does the server actually do with it? This is where it gets personal. This is all about handling the data you sent and, crucially, remembering who you are. See, when you clicked submit on that form, you sent along some data, like your username and password. The server has to unpack all of that, but it also needs a way to remember you for the next time you make a request, because the web is fundamentally stateless. which is just a fancy way of saying it has a terrible memory.
And this is where sessions and cookies come into play. A cookie is just a tiny piece of data that the server asks your browser to hold on to. But for security, you never want sensitive info in there. So instead, the server creates a session to store all your important data safely on its side. Then it gives your browser a cookie with just one little thing inside, a unique session ID. It's like a ticket stub. The next time you visit, your browser just shows the server its ticket, and the server can look up your session and know exactly who you are. Pretty clever, right?
Of course, the server's doing a ton of other things, too. It might be accessing the file system to grab your profile picture, it's definitely parsing the username and password you sent, and most importantly, it's probably talking to a database to either save or retrieve your information. Okay, our journey is almost complete. The server has done all its work, it's processed the request, and it has a result ready to go. But how does it send that information back to your browser in a language that it can actually understand? Well, it does that through something called an API. Now, the most common type of API you'll hear about is a REST API. And honestly, the best analogy for it is a restaurant menu. It gives the client, your browser, a clear, standardized list of options. Your browser can order by asking to get data, post new data, and so on. It's just a predictable, reliable set of rules for communication. And this table just lays it out so perfectly. These menu items, these HTTP methods, post, get, put, and delete, they map directly to the four fundamental things you can do with data: create, read, update, and delete. It's a beautifully simple and really elegant system when you think about it. So the server knows what it needs to do. But what language does it speak when it actually sends the data back? For pretty much all modern APIs, the answer is JSON. And you can immediately see why. JSON, which stands for JavaScript Object Notation, is just clean, human-readable text. It's structured with these simple key-value pairs, which makes it incredibly easy for both computers and, well, us humans to understand at a glance. Okay, one final, tiny step in our journey. To send that nice data object over the internet, the server first has to kind of flatten it and package it up into a single string of text. This is called serialization. Then, when your browser receives that string, it unpacks it back into a useful data object again. That's deserialization. It's literally the digital version of packing a box to ship it and then unboxing it when it arrives. So think about it, from your simple click to a non-blocking Node.js server, through an express router, past all those middleware checkpoints, getting authenticated with a session, and finally getting a response sent back as perfectly formatted JSON through a REST API. It's an entire symphony of technology, all happening in the blink of an eye. So the next time you click, maybe what was once invisible will now be a little bit clearer.